This is day 14 of our Leetcode daily question series, and today's question is minimum number of days to make m bouquets. So we are given with a integer array bloom day and integers m and integer k. So we have to make m bouquets, but for making a bouquet we have to select k adjacent flowers, and the flower will bloom at on the day bloom I. So in the given vector the values will be the days at which a flower will bloom, sorry. And we have to return the minimum number of days you need to wait to be able to make m bouquets. So we have to just return the minimum number of days to make m bouquets by this array, and if we can't find any solution we have to return -1. As in this example, for first day only this flower bloomed, so we can select only this flower, but we have to select 3 bouquets of adjacent pairs one size. So in this only one bouquet can be made. For the second day we can use these two values, this one and this one, so we can make only 2 bouquet here, and at third day we can make 3 bouquets at this flower, as this flower also bloom on the third day. Another example is example 3, in which we need to make 2 bouquet each size having 3 flowers. So we have to select these 3 and these 3, or these 3 and these 3. So in this question the output is 12, as after 12 day we can select these 3 with these 3, or any different pair, these 3 with these 3s. So the 12 is the desired answer, just like the example we discussed earlier, and the constraints are all the values are less than equals to 1 and in the range of 10 to the power 5, and m and k will be less than equals to n, and n will be less than equals to 10 to the power 6. So this question is very similar, quite similar to the very famous question book allocation problem, in which we will check on the basis of solutions, as we can have a search space. In this question we can check now we can see that the search space will be between 1 and 10. Our answer will be in between the range of 1 to 10, otherwise we won't have any answer. So we have a search space which is a sorted space, so we can apply binary search on that space and we can check all the solutions that we can create. Now let's understand the problem more thoroughly. So in this bloom day array, the value of bloom day I, that is 1 here, 10 here, 3 here, 10 here and 2 here, represents the day a flower will bloom. So this flower will bloom on day 1, this flower will bloom on day 10. So we can take this flower only at day 10, only after or at day 10, and same as on the following. So what we can do is, as we are given with m equals to 3, so we have to take 3 pairs and all of 1. So we can take this one, this one, this one after 3 days. So what is the brute force approach is to check for every value every day and check if we can take 3 pairs at any day. So after first day we can take only this value, so this will look like this. After second day the flowers we can take is this one, let's mark it as asterisk, this one and this one. So we can take 2 flowers, and the k represents the number of flowers we have to take adjacently. And at day 3 we can pick this flower, not this, and this flower, and this is our desired answer because we are given with the value m equals to 3, for which we have to return the minimum days for picking the flowers. In this another example, the given value of k is 3, so we have to take at least 3 flowers adjacently to form a bouquet. So in this example we can take these 3 and we have to take these 3 or these 3, because we cannot take this one and this one, because in the question it has said that we have to take adjacent flowers only. So in this solution we will, and given value of m equals to 2, so we have to take at least 2 groups. So in this example the answer will be 12, as after 12 days we can take this pair and this pair, or this pair and this pair. So this is our desired solution. And now the runtime complexity of the brute force approach will be O of maximum of n into n. But this is a very big complexity. So what we can do is we can apply binary search, as we know the search space. As in the given solution, as in this part, the first example, we know our answer will lie in between the minimum value and the maximum value. So minimum value will be 1, of course, as in the given constraints minimum value is always 1, and the maximum value we can find, which is 10. And now we can apply binary search and check what is the minimum value of the days, which is our desired answer, on which we can make the m bouquets respectively. So what we can do is, as in this question, we will apply binary search from 1 to 10. So we will find mid of this array to apply binary search, which will be 1 plus 10 by 2, which equals to 5.5, which will be 5 in integer value. So mid will be here, and we will check that if we can take the solution at 5 days or not. So we will check for this 5, do we can make m bouquets of flowers k adjacently. And for this method, of course, the 5 will be desired solution. So we will move our end pointer as starting pointer, and ending pointer will be here for the binary search, and this will be middle. So as we find our answer, and we have to minimize our answer, so we will move this e to just below the m, just before the m. So e will be equals to m minus 1 if we find our answer, and we will store the answer, so that if in this range there is not any answer, this is our final answer. And after this we have to apply binary search in this range. 1 plus 4 by 2 equals to 2. So we will check on the value 2, and we will get to know that 2 is not a desired solution. So our starting pointer will be moved to the index m plus 1. So it will move to here, and s will be here 3, and will be here at 4, and the middle of these two will be 3 plus 4 by 2, which equals to 3. And 3 will also be a desired solution, as we discussed. 3 is our answer also. So 3 will be a desired solution. And at this point we will again move our ending pointer just before the minimum variable. So e will be here and s will be here, and at this point e will be less than s, so the loop will terminate, or s will be just greater than e, so loop will terminate. Just like same in the binary search, but the different thing here is we have to check if the solution is possible or not. So how we will check is, let's see how we will check that. So for checking possible solution, what we will do is we will just iterate over the array, iterate over given vector, and we will check if this value is less than or equals to our value which we are checking, the mid value from the binary search. And we will check the value, if this value is less than or equals to that mid, so we can take this value and we will just increment our pointer and increment the value of count. And at any point if count equals to k, so we know that we can form a group. So we will increment our bouquet count, and if we get a point that we like, if we are going with count plus, and here we find 6, so we found the value which is greater than mid. Like if we found 10 here, and we are calculating mid for 7, so we will just put the value equals to 0 as count, as we have to take only adjacent values. So here the value of count will be again shifted to 0. So, and at any point if this equals to k, so definitely we will just mark the bouquet counter plus, and if bouquet counter is greater than or equals to m, so this will be our desired solution. So then we will check the other solution by applying mid equals to e minus 1. If this is not a desired solution, if we don't find the desired bouquets of m size of m or greater than m, so we will just increment our s pointer from left to mid plus 1. This will be our whole approach, and let's apply the approach. So let's code for the same. In the starting we will initialize the required variables. So we will initialize int I maxi for checking the maximum value to check the range of the binary search. And now let's take the size of the given vector Bloomday, n equals to Bloomday dot size, and let's mark answer as -1. As in the question it is said that if we don't get any answer we have to return -1, so let's mark answer as -1 from starting. And now we will just apply a loop to get the maximum value. So for I equals to 0, I less than n, I plus plus, we will just get the maximum value by this loop by using maxi equals to max of maxi and the current value Bloomday of I. As the constraints were given for 1 and greater than 1 all the values in the Bloomday, so that's why we had taken maxi equals to 0, otherwise we have taken maxi equals to int min for checking the maximum value. Now let's apply the binary search. So for the binary search we have to declare some variables. S will be 1, as we knew that the minimum range will be 1 and the maximum, the value of S will be 1 and E will be the maximum. So int S equals to 1 and E will be at the maxi. And let's declare mid, that we will use in binary search. Now let's apply the binary search by writing the loop while S less than equals to E. Simple. And now we will just find the value of mid. So mid equals to S plus E minus S by 2. We don't use S plus E by 2 because it can go outside the integer size if we use S plus E. So this is a simple hack to not get trapped in the integer overflow point. Now we will check if the mid is possible answer or not, just like we done before. So we will make a function for that. Let's name it is possible. We will pass mid and m, k, the size of array and the array Bloomday. So if it is a possible answer, we will mark our answer. We will change the value of answer, and what we will do, if we have the answer, we will shift the value of E equals to mid minus 1. So E will be equals to mid minus 1. Now if we don't got our answer, so what we will do is, in the else case, we will write S equals to mid plus 1 to check further values. And after the execution of this whole loop, we will just return our value, return our answer, which will be our final answer to return. And now how we will check the values. Now let's see. And how we will check the possible solution is, we are defining another is possible, which is a boolean function. So we'll write the boolean function here. Bool is possible. We have taken the value int mid, int m, int k, int n, and the vector of integer type and Bloomday. Now let's write the function. So as we discussed, if it is a possible solution, how it can be a possible solution? If we can make this pair. So if the count of these pairs that we are making is greater than or equals to the value m, so it is a possible solution. Now let's declare the variables we will be using. I, we can use j. Let's declare more variables so we don't have to worry about any variable later. So we don't have to declare any variable later. So now let's run a loop in this array only. So for I equals to 0, I less than the size of array, I plus plus, and in this loop what we will do is just iterating over the array and checking if the value is less than or equals to mid, as I discussed earlier. If this happens, count will be plus plus, count will be incremented. Otherwise, as we don't got adjacent values, so count will be just again shifted to 0. So in the else case, count equals to 0. And now if count was greater, if count equals to k, so at any point, like in this case, if we are counting the values and we got 1, 2, 3, which is equals to k. So now we have to again decrement the count equals to 0, and we will mark the counter of bouquet plus 1. that we are using as bouquet variable. So if countable equals to k, what we will do is we will just write bouquet plus plus, and count will be shifted to 0. And after this, now if the number of bouquet we can create is greater than equals to m, so we will return true, otherwise we will return false. Let's close the for loop here. And now if the count of bouquets we can create by the solution is greater than equals to m, we will return true, otherwise in the else case we will return false. And that's all. It will be our desired solution for this question. Now let's submit our code. So our code is accepted. Thank you for watching.